This is Euclid Book 10, proposition number 90. And it says, we're going to find the sixth apotome now. Alright. Let a rational straight line A, that's this one right here, be set out, and three numbers, E, B, C, and C, D. Now let's find those three numbers. Well, here's E right here. Where's BC? Well, there's BC right across here. Where's CD? That one's right across here. Not having to one another the ratio which a square number has to a square number. And further, let BC right here also not have to BD. Okay? So this does not have to this. The ratio which a square number has to a square number. Fine. Let it be contrived that as E is to BC, as this is to that whole length there, so is the square on A, which is this one right here, has to the square on FG. Okay? So, we're going to form a ratio, okay, as this is to this, as this is to this, so as this is to that. And as BC is to CD, as this is to this, so as this is to that. That's by Euclid Book 10, proposition number 6, forism. Okay? Now this is square FG here, this is square GH right here, in case you're wondering. Okay. Now, since as E is to BC, as this is to this whole line right across here, so is this is to that, which is A is to FG. Okay? Therefore, the square on A is commensurable with the square on FG. These two areas are commensurable. That's by Euclid Book 10, proposition number 6. But the square on A is rational. This is rational. Therefore, the square on FG is also rational. It's rational. Therefore, the line FG is rational. This is rational. And since E has not to BC, this does not have to this, a ratio which a square number has to a square number, neither has the square on A to the square on FG, the ratio which a square number has to a square number. So this area does not have to this area the ratio which a square number has to a square number. Therefore, the length of A is incommensurable with the length of FG. This length and this length are not commensurable. This is by Euclid Book 10, proposition number 9. Again, since as BC is to CD, as this is to this, as the whole length is to this part, so is the square on FG to the square on GH. As this is to this, so as this is to that. Okay, that's by Euclid Book 10, proposition number 6. But the square on FG is rational. This is rational right here. Therefore, the square on GH is also rational. This is rational right here. Therefore, the length of GH is rational. This is rational right here. And since BC has not to CD, this does not have to this, the ratio which a square number has to a square number, therefore, neither has the square on FG have a ratio to this which a square number has to a square number. Therefore, the length of FG is incommensurable with the length of GH. This is by Euclid Book 10, proposition number 9. And both are rational. FG is rational, GH is rational. Therefore, the lengths of FG and GH are rational straight lines. They're only commensurable in square. Therefore, FH is an apotome. This is by Euclid Book 10, proposition number 73. I say next that it's also the sixth apotome. We're now going to say that this is the sixth apotome. How are we going to prove that? For since, as E is to BC, as this is to this whole line right across here, so is the square on A to the square on FG. So as this is to this line, so as this is to this. This is a ratio. Alright, And as BC is to CD, as this is to this, so is the square on FG to the square on GH. So as this is to that. Therefore, XI quali as E is to CD, as this is to that, so is the square on A to the square on GH. This is by Euclid Book 5, proposition number 22. But E has not to CD. This does not have to this a ratio which a square number has to a square number. Therefore, neither has the square on A to the square on GH. This does not have to this a ratio which a square number has to a square number. Therefore, the length of A is incommensurable in length with GH. This is incommensurable with that. That's by Euclid Book 10, proposition number 9. So therefore, neither the straight lines GF or GH, okay, neither this line nor this line, is commensurable in length with the rational straight line A. This is not commensurable with A. This is not commensurable with A. Now let the square on K, well here's the square on K right here, okay? And we all know how we're coming up with all these squares, okay? Like here, the length of A, you take the length of A and you make it into a square and all four sides of the square are A. Same thing with FG, same thing with GH, and same thing with K. Like I said, with K, you're just going to take the whole length here, you're going to turn it into a square, and all the sides of that square is going to be the length of K. That's how that works. We have done this so many times. So, let's go back. Now let the square on K, which is this one right here, be that by which the square on FG is greater than the square on GH. What does that mean? It means that if you add this area to this area, you get that one. That's what it means. Since then, as BC is to CD, as this is to this, so is the square on FG to the square on GH. So as this is to that. Therefore, convertendo, as BC is to BD, as this is to this, so as the square on FG is to the square on K, as this is to this. Okay? As this is to this, so as this is to that. That's what Euclid's saying. Euclid Book 5, proposition number 19, Porism says that. But BC has not to BD. This does not have to this the ratio which a square number has to a square number. Therefore, neither has the square on FG, which is this one right here, to the square on K. This does not have to this the ratio which a square number has to a square number. Therefore, the length of FG, this whole length right across here, is incommensurable with K. This is by Euclid Book 10, proposition number 9. And the square on FG is greater than the square on GH by the square on K. This is bigger than this by this. So in other words, if you add these two together, you get that. Okay. Therefore, the square on FG, so right here, is greater than the square on GH by the square on a straight line incommensurable in length with FG. And neither the straight lines FG and GH, neither this line nor this line, is commensurable with the rational straight lines A set out. This is not commensurable with this, and this is not commensurable with this. Therefore, FH is a sixth apotome. Alright, now that we've found that, we can go on. I will tell you more in a future video, so stay tuned.